Any other questions? And again, if you wrote sine of 45 degrees or cosine of 45 degrees, if you left it as 1 over radical 2, with me, that's fine. I mean, later on in other classes, you know, they might want you to write it as radical 2 over 2, but they're really the same thing now. So just letting you know. All right. So now we can also get other the trig functions of other angles as well. No, we can do that. For instance, let's suppose we have an equilateral triangle. Each side has length 2, although really it doesn't matter what side length each side is, but for convenience we take it to be 2. But I could have called this any number. Remember, in an equilateral triangle, all the sides are equal to each other. Okay? All the sides are equal to each other. Okay. So what do we do? Well, and also each angle is 60 degrees. Okay? You know, because it's an equilateral triangle. And in an equilateral triangle, all the angles are equal in size. They're all equal to 60 degrees. Excuse me. Okay, so here's what we do. What we can do then is we can actually draw an angle bisector. Okay? So these two angles up here are the same. In fact, since it's a bisector, they're both equal to 30 degrees. So what does that tell us about these two triangles? Well, for one thing, this angle has to be 90 degrees. Okay? And why is that? Well, again, if you add up the angles in a triangle, it's always 180 degrees. So if this is 30, that forces this to be 90 degrees. Okay? Not only that, these two triangles are actually congruent to each other. I mean, you could do angle, side, this angle, this side, right? Same thing over here. The side is the same length, the angle has the same length. You know, angle is still 30 degrees. This side is a common side. So you have side, angle, side. And because they're congruent, that tells us these two sides have to be the same length as well. So these two sides have length 1. Since the whole side length is 2. And now we can actually get the height. How do we do that? Well, Pythagorean's theorem. Specifically, if we take one of these triangles, say the one on the right if you want, to get the height of the triangle, right, to get h, you can use Pythagorean's theorem. In fact, that's what you have to use because we don't know what sine and cosine of 60 degrees is yet. But with Pythagorean's theorem, you get 1 squared, right, plus h squared is 2 squared. So, right, a squared plus b squared is c squared. 1 squared plus h squared is 2 squared. And once you have that, as down here, you know, you just solve for h algebraically. You get h squared is 4 minus 1, which is 3. So h is radical 3. So once you know this has length radical 3, right? Then you can get the trig functions, namely sine of 60 degrees, for instance. Remember, that's opposite over hypotenuse. Opposite over hypotenuse. Opposite over hypotenuse. So you have h over 2. And h is radical 3. So sine of 60 degrees is radical 3 over 2. Okay? Now for 30 degrees, though, this side is the opposite side. This side is opposite relative to 30 degrees. This side is adjacent relative to 30 degrees. So for sine of 30 degrees, you would have opposite, which is 1, divided by hypotenuse, which is 2. opposite over hypotenuse. So that's what we get here. Okay. All right, good, good. And then for cosine of 60 degrees, you would have adjacent over hypotenuse. Again, this is 60 degrees. The adjacent side here is 1. And for cosine of 30 degrees, adjacent side is h, right? Adjacent over hypotenuse. So that's what we have here. And then for tangent, you would have opposite over adjacent. Tangent 60 degrees, again, that's opposite radical, which is h over 1. H is radical 3. For 30 degrees, we have opposite over adjacent, 1 over h. H is, again, radical 3, so there we go. I put those numbers here. You don't have to memorize these because they're in your calculator. I mean, the calculator, they have it in decimal form, though. But that's okay. You just want to make sure you're in the right mode. You know, if you do cosine of 30, but if you're in radians, the calculator is going to think then you want cosine of 30 radians. Okay? If you're looking for cosine of 30 degrees, though, you're not going to get that. So you want to make sure your calculator is in the right mode. I did convert 30 and 60 to radians down here. 30 degrees is pi over 6. So we have these in radians here. Same thing with 60 degrees. Okay? So that's what we get here. Good. Okay. So again, you don't have to memorize these because they're programmed into your calculator. And also on an exam, I'm not going to have you derive these triangles. I will not do that. You know, mostly because it's in the book already, so that I feel like there's no point in me asking you to do that. Are there any questions, though? All right, well, in that case, let's keep going. So here we have some examples that are good to work with. What's nice about these examples is they really show that with a right triangle, if you know the angles and you know the length of one side, you can get the length of every side using trigonometry. Okay, so that's what can happen here. Okay, so again, if you have all the angles, I mean, if you know two of the angles, you know all the angles, right? Because the angles in a triangle add up to 180 degrees. And you know the length of one side, you have the length of every side. Okay, so let's suppose this angle is 37 degrees. This side length is 40. Let's find A, and then without using A, we're going to find C. Well, how would you find A? Well, we have to know what trig function to use. What do we have, though? Well, we have 40, which is the adjacent side, right? So we have adjacent, and the A here, that's the opposite side. So we have adjacent and opposite we're working with. We're going to use tangent. Opposite, right? That's A. The adjacent side is 40. So opposite, adjacent, we're going to use tangent for this. And that's what we're doing. Okay, so that's what we have here. All right, that's good. 37. So again, by using the definition of tangent, tangent of 37 degrees, right, is opposite divided by adjacent, which in this case is opposite A divided by 40. So tangent of 37 degrees is opposite A over 40. So that's what we get here. So that's what we get here. Now we want to solve for A. How do we do that? Well, Let's get A all alone. Here it's actually very easy. You can just multiply both sides by 40, right? You multiply by 40, these 40s cancel, as you can see. The 40s cancel, and we get 40 times tangent of 37 degrees equals A, which means which is equivalent to saying A is equal to tangent of 37 degrees times 40. It's equal to that. Okay, so how do we get A? We have to figure out what tangent of 37 degrees is. That's where the calculator comes in. Again, make sure you're in degree mode. You know, I would try it out, if not now, then soon, and make sure you get these numbers. I know on the iPhone you can get it by turning your phone, you know, rotating it on its side. Then you get a bigger calculator. You just want to make sure you're in degree mode. And once you get this, you just multiply, and you get A is approximately 30.1422.